Okay, graphing, secant and cosecant graphs, there's a couple of ways to do this, but we may as well just use what we already know. So we know that cosecant itself, by definition, is the reciprocal of the sine function. So, so when we take a look at the table for the sine graph, all of the x's are going to stay the same. So like 0, pi over 2, pi 3, pi over 2, 2 pi. Those are just the angles. Those are the x values. Now, we know what the sines are. So I've got my little table off to the side. If we want to turn this into a cosecant graph, really all we need to do is take the sine values and just find the reciprocal of them. So if I wanted to find cosecant, since this is already in green, I'll just go green. Remember that if you take 0 and you do the reciprocal of it, this is going to be undefined. Take the reciprocal of 1, you get 1. Take the reciprocal of 0, you get undefined again. Reciprocal of -1 is 1, and reciprocal of 0 is undefined. Each one of these undefines that we have is going to represent a vertical asymptote. This is where the graph isn't going to exist. So if we take a look at the values in between those vertical asymptotes, you have a +1 and a -1. All that's going to happen is going to bounce back and forth between +1 and -1. It really doesn't look like a whole heck of a lot. So my recommendation on this is maybe we take a look back at, well, what are some of the other values for sine and see what's really happening. So I would grab my calculator. We know some of the sine and cosine, just the sine values. We know some of the sine values of like √2/2, √3/2.5. Let's actually get the decimals for those and see what happens when you get the reciprocals of those so we can take a look at the behavior of the cosecant graph when it gets flipped over. Okay, so I just extended my table to include a pi over 6, a pi over 3, and a pi over 4. And then I know the sine of those, and then I found the reciprocal of them. But having the roots for the graph isn't necessarily going to help us. So I went through and got the decimals for this. So basically what's happening is I know that on the sine curve, if I take a look over here, sine curve, and then we'll just start, actually it doesn't matter if you take which section you take a look at, but if we take a look at this, so start at the origin, we can see that the y values are increasing as we get to 1, so those are my black dots, and then as we move away from 1, or pi over 2, we're going down and we're decreasing as we're getting closer to 0. Well, what happens with cosecant is it takes each one of those values and flips them over. So again, we already know that the reciprocal of 1 is 1. But then if you take these other values, the reciprocals end up getting larger as you move away from and as you approach the vertical asymptotes. So what happens here is that every section, and you can see this a couple of different ways, every section of the sine curve that looks like it's facing down, when you rip where it's now undefined, so you create the vertical asymptotes, and you flip this thing over vertically, you end up with our cosecant graph. So I just like to call it rip and flip. So you rip on the zeros. Now be careful because the zeros are located on the midline. Midline's huge for us. If you rip on the midline and then flip over that portion of the sine curve, you've got cosecant. It's actually really kind of nice. So what we're going to do is we're going to rip and flip the sine curve to be able to get the cosecant curve. Now, big, huge thing here, and we can always get the asymptotes in the domain and the range, everything from the graph itself, is there's no amplitude here. No amplitude at all for cosecant. Not at all. So keep that in mind, which is why when we take a look at the worksheet, I don't ask for amplitude on this. If I ask you for amplitude on this, tell me there's none, because it does not exist for these guys. Okay, secant. Similar. It's just that it's the reciprocal of cosine. So we have the exact same thing. You've got this section of the cosine graph. So if we take a look at any section of the cosine graph at all, section of the cosine graph, highlight that in yellow. We're going to rip where it's located on the midline. On the midline because that's where it would have been 0 originally for the cosine curve, which means when you find the reciprocal of 0, you get undefined. Put your vertical asymptotes through there, like we have here. And then you take the section of the cosine curve. So I'll put a little orange box around it right there. And the reciprocal of -1 is still -1. So they share that point in common. And then you change it so it's flipping in the opposite direction of what the cosine curve is already doing. And again, you can go through and check the numbers on this as well by pulling out the points from the cosine graph. Again, no amplitude at all. Okay, let's actually do an example. So my recommendation, because this is a continuation of what we've already been doing, take your cosecant and just turn it into a sine. So that's the first thing I'm going to do. And actually, I'm going to do this in like a lightish gray. So I have y equals 2. I'm going to turn it into sine x minus pi over 4 minus 1. All you need to do now to start this, and we're just going to go straight to the graph. We'll come back into the other stuff. Don't identify amplitude, period, phase shift, none of that for these answer blanks because this is about cosecant. We just want to create the sine graph. So use what we know about graphing sine and get this sine graph lightly on the graph that's provided for you. And then pause it and then come back and take a look at your graph. And then we can talk about everything else. So pause the video, graph this sine, and graph it lightly on your coordinate plane. Okay, I've got my sine graph on here. Starts at pi over 4. It's got a period of 2 pi, so I went down 8 pi over 4 to the right. And then I plotted my graph. You could have made the table, just like I did in class, or in the last video, or you could have used period, phase shift, amplitude, and what the sine curve looks like to get this guy. Okay, so we want to start with the sine curve. Now, let's actually create the cosecant graph. Okay, so over to our answer first. So I'm going to go ahead and color code my cosecant green. Amplitude, none, or does not exist. Period. The period for cosecant is the exact same period as it was for the sine graph. So this one, the period, was 2 pi over 1, which is 2 pi. It's the exact same period for cosecant. It's 2 pi. The phase shift for this one is right. So we'll do, was right pi over 4 for the sine graph. It's the same for cosecant. It's right pi over 4. So no difference yet. Vertical shift. Down 1. Still down 1. That hasn't changed. Domain, range, y-intercept, even, odd, neither, relative max, relative min, asymptotes, totally different. So now let's take a look and go back to this thing and let's do that rip flip. So any point that's located on the midline, when we do the reciprocal of it, if we were doing the table, because it would have been a 0, means that it is now going to be a vertical asymptote. So we're going to find that location, I'm going to color code it in green, where I hit on the midline. Those are vertical asymptotes. And you don't have to mark them as points. I only marked them so you could see why I was choosing that section. That's because it's on the midline. Now, any other point that's on the sine curve that we actually plotted, where we used amplitude for it, the reciprocal of that is going to remain the same for the cosecant graph. But now what we're going to do, we're going to take this section that I just highlighted in yellow, and we're going to flip it over. So it kind of looks like it's pointing down or facing down. We're going to face it up. So we're going to flip it over completely. Make sure you hit that point that they have in common, which I kind of missed. So let's do that again. I'm going to do the same thing with this section over here. So I'm just flipping it over. The green graph, no gray. So if you ignore the gray part, and you can actually erase it, totally fine. The green part is the cosecant. Okay, so first thing, let's figure out where these asymptotes are at. So asymptotes are vertical, so let's do x equals. It looks like it's going to be well, there's 3 of them. You can pick whichever one you want. The first one is at pi over 4, so I'm going to do pi over 4. Plus or minus. Okay, let's take a look at this. If I went the full distance of the period, that would be from this very first asymptote to this second, or the third asymptote. You totally skip over the guy in the middle. So the distance between the asymptotes is not the period. It's actually half. So we need to go half a period to get to the next asymptote. Well, the whole period was 2 pi, which means half a period is pi. So quick little note. This is half the period. And that's true for all cosecant graphs. Now, once I know where the asymptotes are, I'm going to go directly back to domain, because the graph exists everywhere except where you just said the asymptotes were located. So pi over 4 plus or minus pi n. Okay, the range. Well, the range is negative infinity to positive infinity, except the middle section where the sine graph exists. So if I start from the bottom, looks like I'm going to go from negative infinity, comma. Okay, let's go over here. We'll take a look at this guy on the bottom. Negative infinity to, and I'm going to mark it in red. I'll go over here. Looks like that is going to be at -1, -2, -3. Bracket. Union. Because it's the bottom, or, union means or it's the top. So let's find the top. So where it starts existing again is right there at +1. So this is going to be +1, comma, infinity. Relative max, relative min. Remember, you're looking at the green graph. Don't look at the gray. Relative min, well, let's get a different color on here. Let's do blue. This point in blue, that's a relative min, because it is lower, respectively, to everything around it. So relative min is going to be at 1, 2, 3 pi over 4. Plus or minus, can I look at your graph? Do you see another min on here? No. You would need another period to get to the relative min, which means it's going to be plus or minus the period n, comma, and then that min value right there is at 1. Relative max, back to our graph. This guy in orange, that's a relative max because it is higher than all of the other points around it. So it looks like we're at, 7 pi over 4. Plus or minus, I'd need a full other period to actually see where it is, so 2 pi n, comma, and that is down at -3. And what else do we need? Oh, we need y-intercept. Okay, so y-intercept, we can plug in 0 for x. So I'm going to use my green here. So this is going to be y is equal to 2 cosecant 0 minus pi over 4 minus 1. So that's 2 cosecant negative pi over 4. Make sure you know your unit circle. Negative pi over 4 is down, so cosecant's going to be negative root 2 minus 1. This is going to give me 2 root 2 minus 1. So it's 0 comma 2 root 2 minus 1. Okay, and then even, odd, neither. If we went through and we extended this graph, kind of across to the left, the whole copy-paste thing, this guy is going to be neither. You don't have symmetry to the origin, and you definitely don't have symmetry to the y-axis. Okay. Secant is just like this, except now you're going to start with cosine. So why don't you start with cosines, pause it, see if you can graph the corresponding cosine graph, come back and check, rip and flip, and I'm just going to kind of steamroll right through the rest of this. It's very much like cosecant. Okay, so in gray, I have my cosine graph. I identified that the phase shift is left 6 pi, which means it's also left 6 pi for my secant graph. My period is going to be 4 pi for my cosine, which means it's 4 pi for secant. The vertical shift was up 1 for cosine, so it's still up 1 for secant. Okay, I'm going to do the exact same thing that I just did. I'm going to go to the midline, and any point that's on the midline is going to get flipped over, and its reciprocal is going to become undefined. Then every other point on the graph where I used amplitude, that is going to remain the same, and I'm going to flip that portion of the graph over. Same thing here on the ends. So there is my secant graph in purple. Okay, so asymptotes, let's do that. So my asymptotes are at x equals, you just need to find one of them. It looks like it's at negative 3 pi is one of them. Negative 3 pi plus or minus. It's still half of the period. It's very similar to cosecant. So if the period was 4 pi, then this is going to be 2 pi n. So quick comment, that is still half the period. That hasn't changed. Now that I know where my asymptotes are, I can state my domain. So it's all real numbers. X cannot be where all of the asymptotes are, which I think I just said it was negative 3 pi over 4 plus or minus 2 pi n. And you could have used, wow, it's not 3 pi over 4. Where did I get that 4 from? Negative 3 pi plus or minus 2 pi n. You could have used the negative 5 pi also. Okay, range. All right, let's take a look at this. It looks like it's coming from negative infinity up to, okay, it's coming up as high as that value, which is 0. So it's going to come up as high as 0. Union, or, and then it's going to pick back up again right there at 2. Up to infinity. Okay, relative max, relative min, the exact same thing. Just make sure you're paying attention to respectively the things around it. So if I take a look, let's take a look at this guy in, I think I did them in blue last time. Let's do blue. Take a look at that blue dot. That's actually going to be maximum. It's going to be higher than everything else around it. Because what happens here with the graph is that this thing starts curling back down. So this is going to be a max. So this is a relative max. Whereas this guy up here in orange, that's going to be a relative min because it is lower than everything else around it. So you have to think about respect only purple graph here and respective to the other purple points around it. So relative max looks like it's going to be at negative 2 pi plus or minus. You don't see another one. Oh, you do see another one on here. So if we're here at the very end of the graph at the blue point, the other relative max we can see is over here at negative 6 pi. Those are 4 pi units apart from each other, which means you are going to travel a full period to get it. 4 pi n, comma, and that relative max has a y value of 0. Okay, relative min. The relative min, which was orange, we have at negative 4 pi plus or minus. You got to go a whole period to find the next one, comma, and that y value is at 2. If we want to find the y-intercept, which we do, okay, we take a look back. We could do y is equal to negative secant. It's going to be a half times 0 plus 3 pi plus 1. Those cancel. Y is equal to negative secant of 3 pi plus 1. Make sure you know your unit circle. 3 pi is coterminal with pi, and the cosine value there is negative 1, which means the secant value there is negative 1. So this is negative 1 plus 1. Looks like that's going to be at 2. So our y-intercept is going to be at 0, 2. If we continued this graph, and actually the whole notion that 0, 2 is a point on the graph, 0, 2, that means that is a point. I also know that if I traveled from the relative min and I went 4 pi to the right, that I would end up with another relative min. So it looks something like that in general. That means that this is going to be an even function because you can fold it over the y-axis. Now, you can always extend your graph out further and just take a look. Do you have symmetry to the origin? Do you have symmetry to the y-axis?